This presentation will describe a type of optical wireless networking and its advantages over Wi-Fi for home networks. As technology continues to improve, the need for more bandwidth is going to grow with it. The speed available to average users is far less than what is required by modern applications. High speed is possible, but it's restricted by the last mile in the local loops of networks. For an example, fiber optic backbone is capable of speeds of 100 gigabits per second, but the speed most of the United States currently receives is around 5 megabits per second. That's a major difference. Part of the problem is that wireless local area networks depend on Wi-Fi. There really isn't a viable alternative available now, and the capacity of Wi-Fi is already stretched pretty thin. And the option that avoids the limitation of Wi-Fi is one that many of us have seen, and it's not a pretty picture. This can't be what the future looks like. A new idea that's been developed, one that is not really new at all, but has been adapted for today's technology, is instead of using radio waves, information can be sent on beams of light. Although it's an ancient concept, researchers at Pennsylvania State University have figured out a way to get more data packed into photons. Using infrared light, speeds of more than 1 gigabit per second have been tested. Besides being faster, data carried by light beams is not reduced by using several devices at once. Another advantage is security, since unlike Wi-Fi, a network that uses light would not be accessible outside the walls of your home. The way this method works is ingenious. Other techniques that use infrared suffer from a phenomenon that's similar to echoes caused by the reflecting beams of light, which cause loss of data and reduces data transmission speed. To avoid the echo issue, the research team devised a way to send out multiple copies of the data as an array of infrared beams that fill the interior of a room. A special holographic filter is used to create a grid for the light to pass through. Since the beams all carry the same signal and they are spread out all over the interior space, devices with infrared receivers can be moved around freely and they still stay hooked up to the network. Devices actually receive multiple identical data streams simultaneously, so they can even perform error checking just by comparing information from several beams. The creators of this system believe that it will probably be replaced by a similar optical wireless network based on white LEDs. The LEDs are able to offer even higher bandwidth than infrared and could serve a dual purpose. Industry experts believe that white LEDs will become much cheaper to produce and will most likely replace incandescent lighting and compact fluorescents in homes. So the same bulbs that light up our rooms could also be used to deliver wireless broadband access. And there's still several kinks that need to be addressed in order for this technology to be practical, but if it takes off and it's combined with other advancements such as broadband over power lines, we may soon be experiencing connection speeds faster than we thought possible.